Okay, the next thing I want to talk about is kinds of data. There are essentially two things that describe what kind of statistical procedure you use. And the first is, well, what is it you want to know? That seems the obvious one. The less obvious one, though, is equally, or if not, maybe even more important, is what kind of data do you have? I'm going to differ from the textbook just a little bit. I'm going to talk about 4 levels of data. The textbook groups the groups 2 together, talks about 3, but I think sometimes there's a distinction. So I'm going to talk about the 4. The first kind of data is simply called nominal data. What does the word nominal sound like? Sort of not what I was looking for, but name's what I was looking for. But number comes into play too. Nominal data is just a name. For example, if we go out in the parking lot and count car colors, how many red cars I see, how many blues do I see? Now I'm going to come up with a number, so you can count things that are expressed nominally, and you can find out which is the most frequent and least frequent. But that's about all you can do. I've got 5 red cars, 3 blue cars, and a yellow car. There's no, so you can't add them together and divide by the number of cars to get an average color. You can't do that. But you can tell how many you've got of each kind. So about all you can do is count. You can sort, you can categorize. But there's not a lot you can do with nominal data. I'm going to say this a slightly different way here. Oops. The next high, someday I'll find out how to line these up. And someday I'll teach my computer to spell. The next level of data, and it's a higher level of data, is ordinal data. Okay, same question. What does the word ordinal sound like? It sounds like order. That's exactly what it is. Ordinal data tells you if something is higher or lower, more or less, but it doesn't tell you by how much. For example, let's say we all run a race. And we've got the top 5 finishers, just 1, 2, 3, 4, 5. If all you know who won, you know who finished second, who finished third, and so on. But what that doesn't tell you is how much the winner won by. Might have been 10 minutes, might have been half a second. You don't know. All you know that number 1 finished ahead of number 2. Number 2 finished ahead of number 3, but by probably another distance. So the distance between points is not consistent. The distance between 1 and 2 probably isn't the same as between 2 and 3 and 3 and 4 and so on. So all it tells you is the order. Now that's a little more than nominal, because with nominal there wasn't any better or worse, or higher or lower, or more or less. Red is not better or worse than blue. It's just different. So you don't have the order in nominal data. In ordinal data, you have the order. So you've got everything nominal data has plus something else. And that's true as we climb up the different levels. So the next level of data is interval data. Most educational data is interval data. For example, let's talk about test scores. You mentioned test scores a minute ago. Let's say we're giving traditional classroom tests where you score somewhere between 0 and 100. Is the difference between 100 and 90 the same as the difference between 90 and 80? Yeah, 10 points is 10 points. It's 10 points higher. So what happens is, not only do I know that 100 is higher than 90, I know how much more 100 is than 90. because the interval is consistent throughout the scale. And it's interval in the next kind of data that your textbook groups together. So you know the order, just like ordinal data, but now you know by how much. Now the other kind of data I do want to separate out, and the two highest levels of data, there's not much difference in terms of what you can do with them statistically or not, but sometimes it's more important to more specifically classify. The highest level of data is called ratio data, and I can't really fully talk about interval data without talking about ratio data. Ratio data is everything. Okay, I'm gonna use a term that's gonna just throw you off for a second. You gotta say, what's that? Ratio data is everything interval data is, except it has a true zero. Clear enough? Okay, what the heck's a true zero? A true zero is this. If you've got a zero on the scale, it means the complete absence of anything, whatever you're trying to measure. It also means the proportions hold up. Let me give you an example of ratio data. Weight. If something weighs 0, does it have any weight to it? No. And here's the ratio part. Is 50 pounds twice as heavy as 25 pounds is? Yes. Does the person making 100 on the test know twice as much as the person making 50? Maybe not. Kind of depends on a lot of stuff. Does the person who made 0 know absolutely nothing about that? Made 0 points, but does it indicate 0 knowledge at all? And probably not. Probably doesn't indicate 0. So interval data doesn't have a true ratio. Doesn't have a true zero. Ratio data does. Let me give you another specific example. You'll have to help me with this one. I'm not much of a cook. So let's say, can you? I don't know. Tell me how long you can cook something at. I have no idea. I don't care what it is. How long could you say bake something and make it palatable? Give me a number easy to work with. 50 minutes. What can I bake at 50 degrees for how long? How long? What temperature, I mean? Okay, 350. So I'm going to, okay, 30. I'm going to use the 50 and the 400 because those are easy numbers. So I'm going to say 50 minutes at 400 degrees. That'll work for something, agreed? Gail, I'm pretty close to your 30, 425. So that'll work for something. Could I bake it maybe? Could I maybe turn it down a couple of degrees and maybe go a minute or two longer? Could I do that and still get kind of the same thing? Okay. Well, how about if I do this? How about if I bake it 100 minutes at 200 degrees? Shouldn't that work out the same? See, you understand something about true zero after all, because you know that wouldn't work. So you can't just double one and half the other. Now, minutes or time is ratio data, but degrees is not. Now, I assume by 400 to 200 we're talking about Fahrenheit, right? Okay, so scientifically speaking, what do degrees measure? What does temperature measure? It measures heat. Scientifically speaking, what is heat? Energy. What kind of energy? Yeah, but from a biological standpoint, microbiological, Heat is molecular movement. I know you were going to get there. So heat is molecular movement. So if it's 0 degrees, which it was dang close today, if it was 0 degrees, does that mean there's the absolute absence of heat or any molecular movement? No, it does not. So Fahrenheit is interval, but it's not ordinal. Is 50 degrees twice as hot as 25 degrees is? No. It's 25 degrees hotter, but it's not twice as hot. So the proportions don't hold up with temperature. They do hold up with weight. If that were true, then I should be able to bake this thing at 200 minutes at 100 degrees. That's not going to work. Or shouldn't I be able to bake it at for 400 minutes? You see where I'm going with this, kind of silly. At 50 degrees. That should work. How about I could just go one more. 800 minutes at 25 degrees. That's where the term freeze or burn comes from, by the way. You know, none of those things work. I mean, yeah, you can go a little longer here, a little less heat there, or a little more, a little less, but you can't half one and double one. Any photographers here? If you know anything about photography, you've got two things. You've got shutter speed and lens opening. You can half the shutter speed and open the lens twice as far and get the same picture, except assuming movement's not, if it's a still picture. Or you can go the other way. That'll work because those are both ratio numbers. We're both ratio data, lens opening and shutter speed. But because one of these is not ratio data, one of them is just simply interval data, you can't use the same proportions with both of them. Yeah, 50 minutes is half as long as 100 minutes, but 400 degrees is not twice as hot as 200 degrees. That's why they don't work together very well. Now, for our practical purposes, that doesn't matter because, again, as long as you've got interval data, you can do most of the stuff we want to do in terms of educational research. Now, sometimes we have some strange mixtures, too. Sometimes we have... when we were going over the syllabus a little bit ago, you saw the grade scale and the number of points and percent it takes. You've all been through undergrad school and have master's degrees, and you're familiar with GPAs. And you might have a 0, 1, 2, 3, or 4 without any pluses or minuses, or you might have some pluses or minuses in there. I don't know. At any rate, what kind of ordinal data, or what kind of, yeah, there's the answer to the question. What kind of data is a GPA for the semester? It's ordinal. Or even the number of points you earn for a particular course. It's ordinal. 4 is higher than 3 because A is higher than B. But it might be just 1 point higher, or it might be 20 points higher. You don't know. So, but think of what we do with GPA. When you put a bunch of that kind of data together, you know, your GPA is 3.265. That sounds pretty interval data. Well, it's higher than 3.165, isn't it? By 1/10 of a point. We say that. So sometimes we have enough ordinal data to where we can kind of treat it like interval data, if that makes sense. When you put a bunch of stuff together, and we just kind of pretend that we're going to promote it to interval, even though it's based initially on ordinal data. So there's this sort of weird, strange relationship between all the levels of data. And what we're going to do in this course, we're going to start off, well, we're going to use the different levels of data, and we're going to get into some procedure for most of the last half of the course, about a third of the way through or so, where we're going to have at least interval data for the most part. But then the last thing we're going to do in the course, the last procedure, is going to be relying back on nominal data again. So, questions about levels of data. Again, I am walking mostly through still chapter 1. Okay.